Welcome to Tomorrow Unveiled. I have to say, looking at the calendar, it is January 31st, 2026. And if you have been paying even the slightest bit of attention to the news this week, you might be feeling a mix of exhilaration and, honestly, a little bit of exhaustion.
It has been a monumental week.
Okay.
Really. I think we're going to look back at the last 7 days as a genuine pivot point in the timeline of artificial intelligence.
I know we say that a lot. It feels like every other week there's a new breakthrough.
Right. Another model gets another point on a benchmark.
Exactly. But the transition from 2025 to 2026, and especially this last week, it feels qualitatively different. It's not just a calendar flip. It feels like we are watching the ground shift beneath our feet in a way that's less about hype and more about, I don't know, infrastructure.
That's a very, very astute observation. It feels different because the fundamental theme is changing. For the last couple of years, really since this whole boom started, we've been in what I'd call the generative phase.
Right. We've been treating AI like a really smart, occasionally hallucinating chatbot or, a party trick.
The party trick. That's a perfect description.
Write me a tome about a cat in the style of Shakespeare. Draw me a picture of a futuristic city made of cheese. It was all about creating content.
Exactly. It was
Yeah.
novel, it was creative, it was fun. But the data we have from this week, and our research team has been incredibly thorough here, suggests we are leaving that novelty phase behind.
And entering what?
We're entering the integration era, or perhaps more accurately, the agentic era.
Agentic. Okay, that is the buzzword of the month. I've seen it everywhere. But let's actually unpack what that means before we get into the news. Because to me, agentic implies agency. It implies action.
Precisely. You've hit it on the head. It is no longer about asking an AI to write a poem. It's about AI acting as a digital employee.
The digital employee.
It's about execution. It's about doing rather than just talking. It's the difference between asking a colleague, hey, how would you file these taxes?
Yeah.
And saying, file these taxes for me.
That is the perfect way to set the stage for what we're about to discuss. We aren't just chatting with bots anymore. We are hiring them. We are delegating.
We are?
And today, on Tomorrow Unveiled, we are going to take a deep dive into 5 specific stories from this week that prove this shift is happening right now in real time.
And we have quite the lineup. We're going to talk about a viral sensation that's been causing absolute chaos on social media.
Oh, yeah.
Then there's a massive industrial-grade model from China, the hardware that powers everything. A really surprising comeback from a legacy internet giant.
A name I have not thought about in this context for years.
And finally, a breakthrough in pure science. It covers the whole stack.
It is a packed show, so here is the roadmap for everyone listening. First, we are going to unpack the saga of OpenClaw, the local first agent that everyone is talking about.
The lobster bot.
The lobster bot, yes. Then we're looking at Moonshot AI's Kimi K2.5 and this mind-bending concept of agent swarms.
That one is particularly fascinating from an architectural standpoint. The engineering behind it is just incredible.
After that, we'll get into the infrastructure beast NVIDIA's new Rubin platform and the rise of these so-called superfactory.
Can't have the agents without the power plants.
Then, the comeback kid. Yahoo Scout.
Yeah.
Yes, Yahoo is back in the search game, and we need to talk about why that actually matters. And finally, we'll look at OpenAI's Prism and what it means for scientists.
It's high energy, and there's a lot of optimism in the air, but we also need to stay grounded. The pace of change here is thrilling, but it brings some serious risks we need to discuss, especially when it comes to security.
Absolutely. Okay, let's unpack this. Let's start with the story that has absolutely dominated the tech discourse for the last 5 days. The viral phenomenon of late January 2026. OpenClaw.
This is such a Wild West internet story. It has everything. Trademark lawyers, crypto scammers, and a piece of technology that is actually quite revolutionary if you look past all the noise.
It's been impossible to miss. So for those who maybe missed the drama, our research team put together a timeline of what happened. This project started out as something called ClaudeBot.
Right. A clever, if somewhat legally dubious, play on words. It's clearly referencing the Claude model from Anthropic.
Which suggests it was likely fine-tuned on it, or at least heavily inspired by it.
Most likely, yes. And that's where the trouble started.
But then, almost immediately, the developers ran into some legal headwinds. Apparently, Anthropic, the makers of the Claude model, weren't too thrilled about the name's similarity.
Which you can't blame them.
No, fair play to them. You have to protect your IP.
Absolutely. In this market, branding is everything. You don't want confusion between an official, safety-aligned enterprise product and this sort of cowboy open source tool that's running around giving itself root access on people's machines.
We'll get to the root access part in a second because that's critical. So they had to rebrand. And this is where it gets funny. They changed the name to Moltbot.
Moltbot?
Yes, Moltbot.
I don't love it.
The metaphor being a lobster shedding its shell to grow.
It's evocative. Maybe a little too biological for a piece of software. It's a bit creepy.
The internet seemed to agree. But during that brief window, that 24-hour period during the molt phase, absolute chaos ensued. Our researchers found this incredible detail. When the project tried to switch their social media handles from the old name to the new one,
Oh, no.
crypto scammers were just waiting.
Of course they were. They used sniper bots, I assume, to instantly register the old handle the second it was abandoned.
Exactly. They hijacked the old handle, launched a fake meme coin associated with the project, and the price it spiked and crashed in minutes.
Wow.
Millions of dollars in purely speculative value, just appearing and then vanishing into thin air, all while the actual developers are just trying to rename their GitHub repository.
It really highlights the volatile, almost insane environment these tools are being released into. You have serious technological development happening right alongside this speculative financial mania.
It's distracting.
It is, but we shouldn't let it distract us from what the code itself actually does.
Agreed. They eventually settled on a new name, OpenClaw,
Much better.
which frankly sounds much cooler and keeps the lobster theme. But let's move past the branding drama and talk about what this thing actually is, because that's the real reason it went viral. Why is everyone trying to install this thing?
The best shorthand I've seen is Claude with hands. But even that simplifies it a bit too much. Until now, if you used a model like Claude or GPT-4, you were largely confined to a chat box. You'd say, plan my week, and it would give you a text list. It was passive.
Right. It gives you the recipe, but it doesn't cook the meal.
That's the perfect analogy. OpenClaw is different. It's an agentic workflow designed for the desktop. It doesn't just output text. It has permission to execute commands on your computer.
It hooks directly into the terminal.
Directly. That's the game changer.
Okay, so when we say hooks into the terminal, what does that actually look like for a non-developer user? What does that mean?
It means it can navigate your file system. It can open files, read them, edit them, and save them. It can run scripts. It can install software. It can basically do anything you can do with the command line.
And the other critical differentiator here, and this is why we're seeing such a surge in interest from the privacy community, is that it is local first.
This is massive. This is the other half of the story.
Yeah.
Our team saw reports that demand for the Mac Mini has actually spiked this week.
The Mac Mini.
Really? Specifically the high-RAM models. People are buying dedicated hardware for this.
Why the high RAM? What's the connection?
Because if you want to run a model that is smart enough to be an agent, not just a simple autocomplete tool, but a real reasoning engine, you need to load a significant amount of weights into memory. We're talking about 70 billion parameter models, usually quantized down, but they still eat up 32 to 64 gigabytes of unified memory if you want them to be snappy.
So people are buying hardware specifically to run OpenClaw because they want what they're calling sovereign AI.
Correct. It's about data sovereignty. Think about it. If you have an AI that has access to your emails, your calendar, your private files, do you really want that running entirely in the cloud? Do you want to pipe your entire digital life through an API owned by a mega corporation? For a lot of people, the answer is a hard no. OpenClaw runs on your hardware. The thinking happens on your silicon. It keeps the data execution local.
So what are people actually doing with it? Our research team dug up some of the use cases that are popping up, and it really ranges from the mundane to the pretty complex.
And honestly, the mundane stuff is actually where the real productivity gains are hiding. Things like managing calendars or meal planning.
I saw one of those. A user has it integrated with Notion to plan meals for the week. It checks a text file inventory of their pantry.
Cross-references it with recipes online, and then creates a shopping list.
That sounds like a dream. But I imagine setting that up isn't exactly plug and play yet. It's not something my mom could do.
Oh, no, not at all. It requires some tinkering. You have to grant permissions, set up the environment, write a good initial prompt. But then you have the more adventurous use cases.
Right. We're seeing people use it to negotiate car purchases.
This one blew my mind.
Literally having the agent handle the back and forth emails with multiple dealerships to get the best price on a new car.
I'm so curious how effective that actually is. I mean, does the dealer on the other end know they're talking to a bot?
Probably not. If the prompt is good enough, it just sounds like a very persistent, very annoying customer who replies instantly at 3 in the morning.
A tireless negotiator.
Exactly. But then there's the crypto angle again. It always comes back to crypto. Airdrop farming.
This is fascinating. And ethically, yeah, well, it's gray. Very gray.
Walk us through this. How does an agent farm an airdrop?
So in the crypto world, new networks often reward early users who test the system. Usually you have to go in, click a bunch of buttons, swap some tokens, bridge assets from one chain to another. It's tedious. It's grinding.
So people are setting up OpenClaw to automate this activity across dozens of different blockchain testnets.
Precisely. Bot logs in, connects a crypto wallet, performs a series of pre-programmed transactions, interacts with protocols. It's basically mimicking human activity to look like an engaged early user.
So the agent is just running 24/7 across multiple accounts, trying to qualify for these future token rewards.
Exactly. It's essentially a botnet, but for personal profit. It's automating the grind.
The capability is just incredible. But, and here's where it gets really interesting and a little scary, there is a catch. A big one.
There is always a catch.
You mentioned it earlier. You called it a Faustian bargain.
I did. Look, security, computer security is all about boundaries. Usually, we sandbox AI. We keep it in a browser tab so it can't hurt anything on our system.
Right. The worst it can do is say something rude or get a fact wrong.
But OpenClaw works because it removes those boundaries. That's its entire purpose.
Yep.
You are giving an autonomous agent root access, or at least near root access, to your machine.
So if it hallucinates, if it makes a mistake.
If it hallucinates, it's not just giving you a wrong answer in a chat window. It could misunderstand your command and delete a critical system directory. It could email the wrong person with sensitive attachments. It could execute a terminal command that opens a security port to the wider internet.
And because it's running in the terminal, it's often a black box, right? You just see text flying by. But do you really know what arm-rf command it just queued up before you hit enter?
Exactly. And unlike enterprise software from a big company, this lacks rigorous professional security auditing. It's open source code, which is great for transparency in theory.
In theory.
But the average user installing this on their new Mac Mini might not realize they're essentially handing the keys to their entire digital house to a very smart but occasionally very confused lobster.
It's a risk-reward ratio that everyone has to calculate for themselves, but it clearly signals this bigger trend that we started with. We are moving from conversational UIs, just chatting, to delegative UIs.
That is the key phrase right there. Delegative. You are delegating authority. You are becoming a manager of a digital workforce, even if that workforce is just one agent running on your desktop.
Speaking of digital workforces, let's scale this up, because this is where things get really wild. We're going from a single lobster on a Mac Mini to a swarm of experts in the cloud. We need to talk about Moonshot AI and their new model, Kimi K2.5.
This is the heavy hitter of the week. While OpenClaw was winning the viral war on Twitter, Moonshot AI was quietly redefining the industrial landscape.
And this is a Chinese company, right? Based in Beijing.
Yes, and Kimi K2.5 is an absolute monster of a model. Our team's report says we were talking about 1.04 trillion parameters.
Trillion parameters. I mean, that number is so big it's almost meaningless. But that puts it in the same weight class as GPT-4 or the larger Llama models from Meta.
It does. But usually a model that big is incredibly slow and expensive to run.
Right. It's a gas guzzler.
A huge one. But this is where the architecture really matters. Kimi uses something called a mixture of experts, or MOE. Now, we've heard this term before, but Kimi is taking it to a new extreme.
Okay, let's unpack this for the listener who might not be an AI engineer. Break it down for us. What is a mixture of experts?
Think of a standard, dense AI model, like a single genius who knows everything about every topic. Every time you ask a question, no matter how simple, that genius has to access their entire brain, every single neuron, to give you an answer.
That takes a lot of energy. It's like firing up a supercomputer just to ask what the capital of France is.
Precisely. A mixture of experts is different. Imagine a massive library filled with hundreds of specialized experts. You have a mathematician, a poet, a coder, a biologist, a historian.
Okay.
When you ask a question, a router, think of it like a smart receptionist, listens to your question and decides which 2 or 3 experts are needed to answer it.
So if I ask a math question, the receptionist just points to the mathematician and maybe the physicist, and everyone else, the poet, the historian, they just stay asleep.
Exactly. They don't use any energy.
Right.
With Kimi K2.5, even though it has over 1 trillion parameters total in the library, it only activates about 32 billion parameters for any given token it generates.
That is a huge, huge efficiency gain. You get the knowledge base of 1 trillion parameters, but the run cost of a much, much smaller model.
It saves energy, it saves cost, and importantly, it increases speed. But the real wow factor here isn't just the MoE architecture, it's the agent swarm capability.
Agent swarm. It sounds like a sci-fi movie villain, but in practice, how does this differ from just asking ChatGPT a really hard question?
It feels like sci-fi when you see it in action.
Mm.
Most models today work sequentially. You give them a complex task, like write a business plan for a new coffee shop, and they do step 1, then step 2, then step 3. It's linear processing.
Like one person trying to build a house by themselves, first I have to pour the foundation, then I can frame the walls, then I can do the wiring. If I get stuck on the wiring, the whole project just stops.
That's a perfect analogy. Kimi K2.5 acts like a general contractor.
Right.
If you give it that same complex research or coding task, it can spawn into 100 specialized sub-agents.
100.
100 concurrent threads.
Yeah.
So using your house analogy, it doesn't build the house itself. It hires a framer, an electrician, a plumber, and a roofer, and tells them all to get to work at the same time.
But how does it coordinate them all? I mean, that's the hard part of being a contractor. If the plumber puts pipes where the electrician wants to run wires, you have a huge mess.
That's the secret sauce of the Key 2.5 orchestration layer. It's hierarchical. You have the main manager agent that first breaks down your prompt into all the subtasks. Then it assigns those tasks to the specialized subagents. And then, this is the critical part, it aggregates their results and resolves conflicts between them.
So the manager agent is the one saying, hey, plumber, you need to move your pipe 2 inches to the left because the electrician needs that space for a junction box.
Exactly. And it does this in a constant feedback loop. Our research indicates that for complex workflows, like deep market research or full-stack software development, this parallel approach cuts the task completion time by an average of 4.5 times.
4.5 times faster. That is massive. That's the difference between waiting all afternoon for a result and getting it in under an hour.
It changes the economics of complex work. If you are a developer, instead of debugging one file at a time, you can have the swarm analyze and debug the entire repository simultaneously.
And it's not just text agents. The report mentioned Kimi is native multimodal.
This is a term we need to clarify because a lot of companies throw it around. Many models claim to be multimodal, but they're actually just stitching together different separate models, one for vision, one for text, one for audio.
So it's more like a committee than a single brain.
Right. Native multimodal means the model was trained from the ground up on mixed data. Text, images, video, code, all jumbled together.
What does that mean in practice for the user? What can it do?
It means it doesn't just see an image by translating it into a text description for another model. It understands the raw visual data in the same way it understands text. It can watch a video of a software bug, literally watch the screen recording of your mouse moving and clicking, and understand the temporal flow of what went wrong, then write the code to fix it.
Wow. Or I could draw a UI mock-up on a napkin, take a picture of it, and it could write the code to build the website, understanding the spatial relationships perfectly.
That's the promise, yes. And significantly, this model is mostly open source.
Which brings up the whole geopolitical angle. For a long time, the narrative has been that the proprietary U.S. models, GPT, Claude, Gemini, were just untouchable at the top.
Kimi K2.5 really challenges that dominance.
Yeah.
It shows that the open source community, and specifically the Chinese tech sector, is competing at the absolute frontier of capabilities. They aren't just copying anymore. They are innovating on architecture with things like this swarm orchestration.
It really emphasizes that this is a global race now. We've got the local privacy hackers in the West with OpenClaw and the massive industrial swarms coming out of the East with Kimi. But all of this, the lobsters, the swarms, they all need one thing.
Power.
Compute.
The currency of the realm.
And that brings us to the infrastructure beast, NVIDIA.
The company that is essentially selling the shovels during the gold rush. Although at this point they're not selling shovels, they're selling the massive city-sized excavators.
But these aren't just excavators anymore. We are talking about super factories.
Just a quick pause in this tour of the future. If you're finding this deep dive into 2026 insightful, please take a moment to like this video, subscribe to Tomorrow Unveiled, and consider hitting that new hype button to help us reach more viewers. And of course, be sure to turn on notifications so you never miss an update on the future.
And we are back. We were just about to talk about NVIDIA's new platform. This is the hardware that underpins everything we've been discussing.
The Rubin platform, named after Vera Rubin.
Vera Rubin, the astronomer who provided the key evidence for the existence of dark matter. It's a fitting name, considering how NVIDIA is illuminating the dark matter of AI, all that hidden compute that powers everything we see.
It is poetic. But the technology itself is brutally practical.
So what is the Rubin platform? Because we aren't just talking about a faster chip here. We hear about a new, faster GPU every year. This feels different.
No, the days of just talking about a single GPU are over. NVIDIA is thinking in terms of systems, of entire data centers. The Rubin platform is an example of what they call extreme co-design.
Co-design. That sounds like marketing speak. What does it actually mean for this silicon?
It means they aren't designing a CPU and a GPU separately and then hoping they work well together when they're put on a motherboard. They are designing the Vera CPU and the Rubin GPU as a single integrated unit from day one.
So they're designed to work together perfectly.
Perfectly. They share memory architecture, they share thermal characteristics, they are two halves of the same brain.
Why does that deep integration matter so much?
Because the bottleneck in AI right now isn't just raw math speed, it's moving data around. If you have a trillion parameter model like Kimi, you have to move massive amounts of data from memory to the processor constantly. If the connection between the CPU and the GPU is slow, the GPU just sits there, idle, waiting for data. It's like having a Ferrari stuck in a traffic jam.
So co-design eliminates the traffic jams inside the computer.
Exactly.
Yeah.
And the scale of what they've achieved is just... It's hard to wrap your head around. I saw a stat from our research team about their new NVL72 rack system.
Yes. The NVL72, this isn't a chip, it's a full rack scale system.
For the listeners, imagine a standard server rack about the size of a tall refrigerator. The bandwidth inside just one of these racks is higher than the total bandwidth of the entire internet.
Wait, say that again? One rack.
One rack. If you took all the traffic flowing through the global internet at any given second, every Netflix stream, every email, everything, the NVL72 rack can move more data internally between its own chips than all of that combined.
That is, frankly, it's difficult to even comprehend that. And why do we need that much power? Is it just to make the model smarter, to get to 2 trillion parameters instead of 1?
It's not just about smarts anymore, it's about cost. And this connects directly back to our previous segments. Remember how we talked about agents doing work for us?
The digital workforce, the swarms.
If you have an agent working for you 24/7, scheduling, coding, researching, that costs money. Every thought that agent has requires compute. Every time it iterates on a loop, it burns electricity and time on a GPU somewhere.
Right. If the cost of thinking is too high, you can't afford to have a digital employee. It's too expensive.
Exactly. If we want this to be affordable for everyone, not just mega corporations, the cost of inference, which is the technical term for the AI thinking, has to drop dramatically. Rubin aims for a 10x reduction in cost per token compared to the previous generations.
A 10 times reduction. That is the magic number. If you cut the cost by a factor of 10, suddenly you can have swarms of 100 agents working for you without bankrupting your company.
Precisely. It's all about economics. NVIDIA isn't just building faster chips, they are building the economic foundation for the agentic era. If inference is expensive, AI is a toy. If inference is cheap, AI is labor.
But there's a physical cost too, right? I mean, these super factories must consume immense amounts of power and generate incredible heat.
They do. And that's the shadow over all of this. We are talking about data centers that require gigawatts of power. We are seeing these tech companies form partnerships with nuclear energy providers. The efficiency gains of Rubin are great, but the overall demand for energy is growing even faster.
They're looking beyond just digital agents. The research materials mentioned NVIDIA is moving heavily into physical AI.
Robots.
Yeah. The Rubin platform isn't just for chatbots. It's designed to be the brain for the next generation of robotics.
We saw examples like the Alpha Mayo model for autonomous driving. We're seeing partnerships with companies like Mercedes-Benz to put this tech into factories. We are seeing AI moving out of the data center and into the factory floor.
It's the super factory concept, taken to its literal conclusion. Not just a factory that makes AI chips, but a factory that is run by AI.
It's the convergence of the digital and the physical. Your OpenClaw agent running on your laptop is purely digital. The robot building your car is physical. But they're both running on the same underlying logic, powered by this massive jump in infrastructure capability.
So we have the agents, we have the swarms, and we have the power plants running them. But how do we, the regular people, interact with all this stuff? Do we just have to learn how to type into a terminal?
For a while, it felt like that was the direction things were heading. The user experience has been lagging way behind the core tech, but we are seeing a fascinating pivot from a very, very unexpected player.
This was the surprise of the week for me. I honestly thought it was a typo in our show notes at first.
Yahoo.
Yahoo, the giant that refused to die.
I mean, for a lot of our listeners, Yahoo is the place where they have that old email address they use for junk mail, or maybe where they check their fantasy football scores.
Search.
I thought that war was over. It sounds retro, but Yahoo has launched Yahoo Scout. And it is actually really good. And it solves a very specific pain point that people have with search today.
It's being called the answer engine.
And that distinction really matters. Think about the current Google experience. You search for something, and what do you get? 4 ads at the top, a bunch of SEO spam, and then 10 blue links that you have to click through and read yourself to find the answer.
It's a hunting expedition. You have to go find the answer in the wilderness of the web.
An answer engine is different. It uses what's called retrieval augmented generation, or RAG. It goes out, reads the top links for you, synthesizes the result, and presents you with a clear, concise paragraph that directly answers your question.
It brings a retro, clean feel back to search. I looked at the screenshots our research team provided. It's very minimalist. Less clutter, more answer.
It is. But the crucial innovation here, and this directly addresses a huge complaint about AI search, is the citations.
Right. Because the big problem with ChatGPT is that it can lie so smoothly. It hallucinates with complete confidence.
Yahoo Scout heavily cites its sources. Our team counted about 9 prominent links per query, displayed right there with the answer. It's trying to rebuild the trust that was lost when chatbots started hallucinating facts. It's saying, here is the answer, and here is exactly where I found it.
Now, Yahoo didn't build the brain entirely from scratch, did they? That would be a monumental task.
No, and that's a very smart move on their part. They realized they couldn't compete with OpenAI or Google on raw model training, so they
They were the partners?
They partnered with Anthropic to use the Claude model for the reasoning, the thinking part, and they partnered with Microsoft and Bing for the grounding, the actual index of the web to search through.
So they are basically renting the brain and the library. If they're just wrapping other people's tech, why is this a business? What is Yahoo actually bringing to the table?
The secret sauce. Their proprietary data. We forget, but Yahoo has been around for 30 years. They have something like 500 million user profiles. They have decades of curated data from Yahoo Finance, Yahoo Sports, and Yahoo News.
That is a treasure trove of context that a general model wouldn't have.
It is. If you ask Yahoo Scout about a particular stock, it doesn't just give you a generic definition from Wikipedia. It pulls from real-time financial data, analyst reports, and news articles that Yahoo Finance has been curating for decades. It has vertical depth that a general model often lacks.
And it's integrated right into the existing Yahoo apps. It's not just a search bar on a website.
That's the integration era theme again right there. Scout is embedded in Yahoo Mail to summarize your long email threads. It's in Yahoo Sports to break down the game you missed last night. It validates this trend that AI is becoming the interface for existing products, not just a standalone chatbot you talk to when you're bored.
It's funny, we spend so much time thinking Google would be the one to kill Yahoo, but in the AI age, Yahoo is finding a way to leverage its specific vertical sports, finance, to be more useful in some ways than a general search engine.
Verticalization is a huge trend. General AI is great, but specialized AI, an AI that knows everything about finance or everything about sports, is often more valuable to a specific user.
Speaking of specialized AI, let's move to our final deep dive of the day. We've talked about consumers finding better answers. We've talked about industry-building products. Now let's talk about the ultimate search for answers. Science.
This is OpenAI's Prism.
From the consumer world to the science lab. This is not for writing marketing copy or planning your vacation.
Joe. Prism is a dedicated workspace specifically designed for scientific discovery and academic writing.
Our research team highlighted the problem this is trying to solve, and it really resonated with me from my university days. Scientific work is incredibly fragmented. You've got your raw data in one program, you're writing up your paper in a LaTeX editor.
And let's explain LaTeX for those who don't know. It's a typesetting system used by scientists and mathematicians to write papers. It's extremely powerful for displaying complex equations, but it's notoriously difficult to use. It's code, basically. You aren't just typing, you are programming your document.
So scientists are constantly switching between coding their document, reading reference PDFs, analyzing data, and chatting with colleagues. It's messy and inefficient.
Prism integrates GPT-5.2 directly into a LaTeX native workspace. It's designed to smooth out all of that friction. It helps with the formatting, sure, which is a big help on its own, but it goes much, much deeper than that.
It helps with the actual thinking.
Exactly. It helps solve complex equations. It helps verify logic chains in a proof.
We saw some early reports that users are already using it to make progress on complex theoretical math problems, specifically things called Erdos problems.
That is a very big deal. For the listeners, Paul Erdos was one of the most prolific and brilliant mathematicians of the 20th century. He posed hundreds of problems, conjectures that have stumped the world's best mathematicians for decades. They are incredibly difficult questions about combinatorics, graph theory, number theory.
And these are problems that require rigorous, absolute logical proof. You can't just guess the answer or find a good enough solution.
Correct. And that's why this is so significant. Large language models, at their core, are probabilistic. They are guessers. They're designed to predict the next most likely word. In mathematics, you can't predict, you have to prove. If Prism is helping to solve Erdos' problems, it means we have bridged a critical gap between creative probability and logical verification.
It's moving from creative tasks to verifiable, truth-seeking tasks.
That is the crucial distinction. For the last few years, we liked AI because it could hallucinate creative things, write a story. It didn't matter if it was true, it just had to be good. In science, truth is the only thing that matters. Prism signifies that AI is becoming reliable enough to participate in the scientific method itself.
It's an accelerant for the discovery of truth. That gives me goosebumps a little bit. It suggests that the rate of scientific breakthrough could accelerate dramatically if every scientist has an AI partner that can handle the tedious math and the formatting, freeing up the human to focus on the core hypothesis.
And that really ties all of these stories from the week together.
So let's do that. Let's synthesize. What does this all mean? We've looked at OpenClaw, Kimi, Rubin, Yahoo Scout, and Prism. It feels like a lot of disparate pieces. A lobster, a factory, a rack of chips, a search engine.
It does, but if you step back and look at the whole picture, the research team identified a very clear pattern running through all of them. We are well and truly in the integration era.
So let's break down the key trends. Trend number one seems to be agentic versus generative.
We are moving from creating content to executing decisions. OpenClaw executes commands on your Mac. Kimi executes coding tasks in a swarm. It's all about action. The AI is no longer a bard, it's a builder.
Trend number two, the digital workforce.
Whether it's a personal agent like OpenClaw on your desktop or a swarm of 100 agents in the cloud with Kimi, AI is becoming a teammate. You are no longer the lone operator, you are the team lead.
And trend number three, the rising tension around privacy and trust.
This is the core tension defining 2026, I think. You have the cloud intelligence of Yahoo and OpenAI. It's massive, powerful, and convenient, but it's centralized. And you have the local sovereignty of OpenClaw. It's private, it's under your control, but it's potentially risky and less powerful.
It feels like we're all going to have to make choices. Do we want the convenience and power of the cloud or the control and privacy of our own desktop?
Most likely, we will end up with a hybrid model. A local agent on our machine that manages our private life, which then talks to powerful cloud swarms that handle the heavy lifting. But the friction between those two worlds is where all the drama is going to be this year.
Which brings us to the human element in all this. If AI is the workforce, what are we? What's our job?
We are the managers. There's a new skills gap emerging, and it's happening fast. We're moving away from hiring for execution. Can you write this specific code? Can you file this specific report? And towards hiring for judgment.
Can you direct the agent effectively? Can you verify its work? Can you provide the high-level strategy?
Exactly. Humans need to become the directors, the conductors of the orchestra. This is an optimistic take, but it really does free us up to focus on strategy and creativity. Let the agents handle the grunt work. Let Kimi check the code. Let Prism format the paper. Let OpenClaw schedule the meeting. You focus on why you were doing it in the first place.
It's a brave new world, for sure. 2026 is kicking off with just massive velocity. From lobster bots on our laptops to super factories in the cloud, the infrastructure for a completely new way of working is being laid right now as we speak.
It is. And it's going to be a fascinating year to watch it all unfold.
Before we go, a quick request for our audio listeners. If you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It truly helps us reach new listeners.
And we love hearing your thoughts. Whether you're on YouTube or your favorite podcast app, leave a comment and let us know what you think about the rise of agentic AI and tools like OpenClaw. Would you trust a lobster with your email?
That is the question of the week. And here is a final provocative thought for you to mull over as we close out. As we hand over more and more agency to these tools, letting them book our flights, write our code, and manage our calendars, at what point does the assistant become the manager?
That's a deep question, a really deep one.
If an AI agent can negotiate better than you, plan your time better than you, and execute tasks faster than you, are you still directing it? Or is it just maximizing you? Are you the boss, or are you just the biological bottleneck in an otherwise efficient system?
Something to think about as you go and update your Mac Mini's RAM.
Thanks for joining us on Tomorrow Unveiled. We'll see you in the future.
Goodbye, everyone.